Welcome to today's Science Challenge. I'm George Wolf. Now today's challenge is going to use some pretty simple stuff. I got a pair of lit candles and I got a straw. Now I've got a pretty cool demonstration to show you, but before I show it to you, I'm going to ask you to make some predictions because of course that's what we do a lot of in science. But before I show you this, and before I ask you the question, or maybe after I ask you the question, you're going to want to look up a term. And that term is Bernoulli principle. Because a guy named Bernouli had this one figured out long before you and I. Now, after you look it up, it's going to help you explain and answer this question. And here's the question. I'm going to take this straw and I'm going to blow in between those two flames. I want you to predict for me what's going to happen when I blow in between those two flames. How are the flames going to behave? That's up to you to figure out. Good luck. Okay, you guys ready for this demonstration? I know a lot of you, because I know this is a tricky one, predicted what would happen when I blew between these candles. You predict that I'm blowing air. Of course, the candles are going to move apart, and I might even blow them out, right? Well, let's see if you were right. I bet you that surprised you. I know you all noticed that those two flames bent to the inside. And if you didn't look up Bernoulli principle, you're scratching your head now saying, what's up with that? But here's the thing. For those candles to bend to the inside, something odd had to happen, right? There had to be either a force of suction from the inside or a force of pushing from the outside. And in a way, it was both. And we'll see in a minute that that has something to do with the Bernoulli principle. You see, because by forcing air through there, I'm creating what's called a low pressure system. And that means that on the outside, well, if it's low in here, the opposite of low is high. And so there's a high air pressure system in here, which kind of tends to flow to the low. And so the air rushes in that direction, pushing those flames toward the inside. Now, I could show you, I don't want you messing around with candles at home, but I can show you a very easy demonstration where you can do this. Just take a piece of paper, like so, fold it, or an index card will do, and then just get underneath it, get way down low, and blow gently. You see what happened to that paper? It starts to sink. Watch. I'm going to push the air from underneath it. The air is going to shoot through, which makes a low pressure in there. Look at that. Even as I'm speaking, it's dropping from my air. All right? It's going to make a low pressure in there, which makes a high pressure here. Watch. Ha, how cool is that? Let's go talk a little bit at the board about what the Bernoulli principle is and how it affects this phenomenon. All right, now you guys know I had you look up something called the Bernoulli's principle, and it's not a simple thing. And the definition you find in a dictionary is something like this. Bernoulli's principle says that the faster a fluid flows, the lower the pressure it will exert. But you're probably saying, what fluid did we push here? Is air really a fluid? And that's a darn good question, but you know what? There is a fluid. Of course, it's not a very thick or viscous fluid, it's air. But nevertheless, it's molecules, and molecules that are flowing behave like a fluid. So we can picture air now as a fluid. All right, well, let's take a look at a diagram and see exactly what we did here. Now, here's my two candle flames, all right? And this little X, or this green spot in the middle, shows the straw blowing right in between them. So picture that air going right in between the two candle flames. And now let's take a look at what happened when we blew those. When we blew them, we created a low pressure system right here in between them, okay? And so the air went into the board. Meanwhile, that means outside, it was a high pressure system. And look at those arrows, because guess what's going to happen next? When that high air will start to flow to the low air, those two flames are going to bend to the inside, high to low, and that's what happens. Bernoulli's principle in action. So let's summarize. Air can be considered a fluid. Interesting. Bernoulli's principle says that a fast-moving fluid will have lower pressure. And finally, air under high pressure will always move to a lower pressure. Cool stuff, huh? Listen, I'm George Wolf, and I want you to remember to discuss today's science challenge with your class and teacher. And I'm going to challenge you again next time. But remember this, you're never going to get any answers unless you ask those great questions. Take care.